PartDistillation is an unsupervised self-training method for object part segmentation task. It starts with a strong instance segmentation model, and for each object class, it generates part segments as pseudo-labels for self-training. PartDistillation builds an accurate and diverse part segmentation model without any part labels. We apply PartDistillation for over 10,000 object classes and discover novel parts for each of these classes. PartDistillation makes a state-of-the-art unsupervised part segmentation model. Compared to supervised training, PartDistillation generalizes better in both zero-shot and few-shot setting. Beyond common objects of existing dataset, we conduct manual evaluation for diverse object categories. Here we show that PartDistillation generalizes well to rare objects and it scales nicely to 10K object classes. Now let's dive deeper into the details of our work. First, what's object part segmentation? Object part segmentation refers to the task of localizing and identifying individual parts of each object instance. It provides more detailed and fine-grained understanding of the layout and composition of objects. However, existing part segmentation benchmarks such as PartSculptPart and PartImageNet focus on only the common object categories. These datasets are orders of magnitude smaller than corresponding instance segmentation datasets such as LBIS. Parts are harder to detect, annotate, and properly define. So, why PartDistillation? Supervised learning cannot easily scale since the existing part segmentation datasets only cover less than 100 coarse object categories, each featuring different granularity of parts. Furthermore, supervised models do not generalize well across different object classes such as legs of a dog to a person. PartDistillation addresses this problem through large-scale unsupervised learning. Now I will describe how PartDistillation works. PartDistillation utilizes a strong instance segmentation model and starts with generating initial part segments. It first generates an instance segmentation mask and clusters the pixel-level features within the mask to make what we call part segments. We observe that transformer-based models lead to surprisingly accurate part segments as seen in the image. With further exploration, we have discovered that the selection of pre-training, framework, and layer of features has a significant impact on the quality of the generated part segments. We use mass-to-former trained for instance segmentation tasks and use the penultimate features of the swing transformer backbone. PartDistillation combines with an open vocabulary instance segmentation, enabling it to generate instance segmentation mask for a wide range of class labels. As a result, we are able to generate part segments for more than 10,000 object classes from the ImageNet dataset. Our work is about self-training with these part segments. PartDistillation is a process of refining the part segmentation through self-training with the generated part segments. It consists of part proposal learning and part ranking stages. Combining the two, we have a robust and diverse class-specific part segmentation method we call PartDistillation. For part proposal learning, we first repurpose mass-to-former as a part proposal model. The generated part segments are used as ground truth, and the mass-to-former queries attend to each region. We find that training only the transformer decoder, while freezing the backbone and the transformer encoder, results in the most stable and precise part segmentation. This indicates that much of the part information is already present in the initial instance segmentation model. After self-training, we have much refined class-agnostic part proposal and part-level features from the queries. Part proposal learning makes impressive improvement by more than doubling the average recall of part segments. Next, we describe how we convert the class-agnostic part proposals into class-specific labels. We generate part proposals and corresponding part-level features over all datasets. Generated part proposals undergo post-processing steps and together clustered across dataset for each object class. We define part ranking function as cluster density estimate and assign labels to each part as the nearest part cluster ID. Now, we use all parts with ID as pseudo-labels and self-train all together. We apply part distillation to ImageNet 21K dataset. We filter out classes that do not have clear object definition, and remaining 12K classes are used. We set that each object class has exactly 8 part clusters. We combine with a strong open vocabulary instance segmentation, DATIC, to generate instance segmentation for each image. We first evaluate part distillation in unsupervised part segmentation benchmark. Comparing to the state-of-the-art method, Chaudhary et al., we improve both NMI and ARI metrics by large margins in Pascal part. We also evaluate our method in zero-shot benchmark. We compare the supervised baselines as well as our one-stage baseline in which sub-trains without part proposal stage in part distillation. We show that part distillation generalizes better than supervised training across different datasets in both AR and MIOU metrics. Similarly, we show that part distillation is more label efficient compared to supervised training, especially in low data regime, both in AR and MIOU metrics. Since existing benchmarks can only evaluate common object categories, we conduct extensive manual evaluation and compare part distillation with supervised baselines. Specifically, the supervised baselines are trained on part ImageNet, and we evaluate precision, diversity, and generality on ImageNet classes. Comparing on ImageNet classes that are subtrees of part ImageNet, part distillation does comparably with the supervised baseline in precision metric. Notably, we observe that supervised baseline significantly underperforms when evaluating on non-part ImageNet subtree. This indicates that supervised training is limited to the training dataset and unable to generalize. We also measure diversity of the discovered parts. We ask annotators how many of the parts are unique. We compare the supervised baseline measured on the balanced set of classes with part ImageNet and non-part ImageNet subtrees. Finally, we show that part distillation scales nicely to 10K object classes. Here are some random samples of the part segmentation generated by part distillation. And if you want to know more, please come to our poster session on Tuesday, June 20, from 4:30 to 6 p.m. at West Building Exhibit Halls ABC, poster number 289. Thank you.